Hello, welcome to our next lesson in Algebra 1. Today we are covering Module 1, Lesson 2 of the Engage New York. However, there are extra stuff on here. Okay. All right, so our warm-up graph at the right is about a boy at the swimming pool. Put the letter of each segment next to the part of the story it corresponds with. So we have 4 parts to the story. We have the distance or the elevation in feet here for the y-axis. We have our time in seconds. Okay, and our parts of the story go like this. The boy goes down the slide and underwater. The boy swims to the surface of the pool. The boy sits on the top of the slide. The boy exits the water and climbs the slide. The boy swims under the water for 2 seconds at the same depth. So since we're going to elevation, we have positive and negative and 0. I'm going to assume that this was probably supposed to be the water level. And then up here is above water, down here is below water. So it looks like the boy is below water in 3 areas, above water in 3 areas, but one of the areas overlaps. So C is both below and above water. Now, which part of the story would have the boy both above and below water? So it says the boy goes down the slide and then underwater. So I'm going to go with C here. This is the only place where he's both above and below. So the boy swims to the surface of the pool. So that means he has to be under the pool, under the water to start with, and swims up. That's going to be section E here. This is the only place where he's already under 0, under the water level, and going back up. Okay. The boy sits on the top of the slide. So the slide's out of the water, and if he's sitting there, then he's not changing his elevation. So the place out of the water where the elevation's not changing is choice B. The boy exits the water and climbs the slide. So that's going to have to be A here. I think he comes out of the water and then climbs the slide. So we don't see him actually exiting. We just see him leaving the water. So he's at the edge of the water and he climbs up. And then the boy swims underwater for 2 seconds at the same depth. So the same depth again leaves us a tip off that that should be a slope of 0 because we're not changing elevation. So this is the slope of 0 that's underwater. All right. Now, down below, we're asked to calculate the slope of each one of these pieces of our piecewise function. So I'm going to erase all this stuff off again. Now, when we were in class last time, we calculated slope by just drawing in the triangle, but this time we're going to use our formula that we learned in Math 8. So our slope formula, or rate of change formula, is m equals, remember, y2 minus y1 over x2 minus x1, or the change in the y's over the change in the x's. So the change in the up and down divided by the change in the left and right. So for our A, let's mark our 2 points. So we need to know our points. First one is 0, 0, and the second one is 2, 5. So the change in the y's, well, the y's are 5 here and 0 there. So the change in the y's are 5 minus 0, and the change in the x's are 2 and 0, so 2 minus 0. This will give us 5 halves. Okay. Then we need to know the slope for B. I know the answer already. It should have a slope of 0, but we're going to go ahead and do the work just to show that it does make 0. So for B, remember our first place in B is 2, 5. And our second place in B is at 4, 5. So let's calculate the slope. The change in the y's, well, both y coordinates are 5, so 5 minus 5. And the change in the x's are 4 minus 2. So this is 0 over 2, which is just 0. Okay, so we were correct on it being 0. Now, the one thing to remember about the slope formula is if you start with this y, you need to start with this x on the bottom. Okay, that's the thing that people have trouble with. All right, so looking at part C, our slope here, we started at 4, 5, and we end up at 6, negative 3. All right, so negative 3 minus 5 is our top. And our bottom, the change in the x's is 6 minus 4. This would give us -8/2 for a slope of -4. So here the boy's going upwards, 5/2 is a positive slope. Here the elevation didn't change, and here the elevation is going down, so that he's going downwards. That's him sliding down the slope. Now we know D already. Okay, D is straight across, so that has a slope of 0. Let's skip a little time here. And E, we are starting at 8, and that's -3. And we're ending at 9, 0. Okay, so that's going to be -3 minus 0. Changing the y's. And the x's are going to go 8 minus 9. This will give us -3 over -1 for +3. All right, so those are calculating the slopes without making triangles on the graph, and you'll need to be able to do this on your quiz next time. So what was the boy doing during the segment with the largest rate of change calculated? All right, so positive numbers are always bigger than negative numbers. So our first one is 2.5, that's a 0, -4, 0, and 3. So 3 is the biggest. So what was he doing during our last segment? He was swimming to the surface. Okay, that was part E of the story. How many seconds was the boy underwater during the story analyzed in the warm-up? So let's go back up and look and figure out how many seconds was he under the water. So here is our water level again. Let's get this stuff out of the way. Draw it in blue. Here's our water level, and he was under the water from here to here. Okay, so we don't know exactly where this crosses, but we know it's a little more than 5. So it's going to be 9 minus 5.2 maybe, 5.3, wherever you estimate it to. So I'm going to go with 5.2, which will give me about, let's see, that's 3.8 seconds. Okay, seconds. All right, how tall was the slide the boy went down during the story analyzed in the warm-up? So let's look back up again. So the change in elevation from the water level to the top of the slide, well, that was 5. So the slide was 5 feet tall. All right, let's flip it over and look at the second page. All right, on page 2 here, number 5, we have watch the video of the rolling ball and take a minute to discuss with your table how the elevation of the ball changes with time during the video. So in class, we watched the video and we paused it at a couple of different places, which we'll talk about in just a second, and just kind of wrote out some points about what's going on. Okay, so if you look at this video, the man or woman here, whoever it is, first sits the ball down at the top of the ramp. Okay, so notice they don't like launch the ball, they just rest it there and then let go. So as the ball goes down the ramp, it of course speeds up, okay, because gravity's acting on it, it makes it go faster, and then it cruises across the end. Now we're not worried about the speed, what we want to know is how does the elevation of the ball change, okay? So the speed is going to affect how the elevation changes, but we're not recording the speed. All right, so if we look here, the top of the ramp is at 12 inches. If we follow it around to this side of the table that it's on or something, it's 12 inches to begin with. So one point we could put down would be at 0 seconds, the ball is at 12 inches for elevation. Now obviously at 2 seconds, the ball is 0 elevation, it's on the ground because the video is 2 seconds long. So let's pause the video and see if we can figure out where is the place where the ball first hits the ground, okay, changes its elevation. So here is halfway through the video, 1 second. And we can see the ball has traveled all the way to the ground already, okay? So that doesn't help us there. So let's back up some more. So what we want to do is mark kind of in our head, where is this part? So that's our 1 second. Is about here on that first meter stick, so almost 1 meter over. So if I wanted to do half a second and mark that, I would go halfway in between, okay? And at a half a second, I think we get about 9 inches. So if we follow the edge of the ball over to here, we're about 9 inches at that half a second. So half second, somewhere in here. So we have a point, 0.5 and 9. So if you're recording in your chart here while you're watching the video, then so far we know at 0 seconds for the time, right there underneath the video, we should have 12 inches. And we know at 1 second, we might not put that one in yet, we have 0 inches of elevation. And now we know at 0.5. So put 0.5 on the third one down and mark it as 9 inches, okay? So now let's back up a little bit and find maybe 0.25. So we're gonna go halfway between those two. And if we go to 0.25, it's just barely starting off down the ramp still. So we probably would mark that about 11 inches. So now we have 0, 12, 0.25, 11, 0.5, and 9. So let's go back to 1 so we can help us find the halfway mark again. So if we go, there's halfway at 0.5, and then half of that would be somewhere right in here. Okay, so at 0.75, I'm going to get almost all the way on the bottom. So we're going to probably put that at like 1 inch. And then maybe we would say, oh, 0.8 seconds into the video, we're at 0 inches, okay? So we have enough points now to record because everything after 0.8 seconds is going to be an elevation of 0 because it just stays on the ground, rolls across the ground. All right, so let's get everything in our table and then we'll make a graph and we'll see how our graph differs a little bit than last time. All right, so in our table, we have first entry at time 0 for seconds. This is in seconds. We have an elevation of 12 inches. And then at time 0.25, so 0.25 seconds after the video starts, we're still at elevation 11, and that's because gravity is just starting to act on that ball as it's rolled a little bit. And then at time 0.5, that ball is really sped up because of gravity. It actually dropped 3 inches in that next quarter of a second. And then when we get to 0.75, it's all the way at 1 inch. So it dropped 8 inches in that next quarter second. And then we estimated at about 0.8, we were at 0. And then from every place on is 0. No matter what we pick all the way up to 2 seconds, we get 0 the whole way, okay? All right, so we know our elevation needs to go from 0 to 12. So let's put elevation on our y-axis, same as we were doing last class. And our elevation in this case is in inches. So that's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that all fits on there. And then we're going to go by, let's see, probably by quarter of a seconds here. So this is going to be our time in quarter of a seconds, which is still seconds. But we're going to write 0.25. We're going to write 0.5, 0.75, 1, 1.25, 1.5. Okay? All right, let's do some recording. We know at 0 we get 12, so that's right here. Okay? We know at 0.25 we have 11, so that's right here. We know at 0.5 we have 9, so 0.5 made 9, that's right here. Okay, and then at 0.75 we got 1, so that's way down here. And then at 0.8, which is about right there, we get 0. Okay, and then from there on, it just stays on 0. So there's part of my graph. Now the rest of the graph definitely doesn't make a straight line. And we shouldn't connect each little segment with a straight line. Instead, we know it makes a curve. So we should try to draw in a good curve here. Okay, so there's our whole graph. So it's a little bit different in this case because we actually get a curve here, unlike yesterday where everything was a straight line. We had a constant speed that people were traveling usually, and we were able to get that rate of change. This time we get a curve, So it's more difficult to calculate the rate of change for the whole curve. We can only do it for parts of the curve. All right. All right. So now we're going to open up our module. So to Module 1, Lesson 2. And on page S4 and S5, we're going to do two of the problems. So the first problem is this one. So it's first page in Lesson 2. It's our classwork. We have an exploratory challenge. And we're going to watch a man jumping from 36 feet above the ground into 1 foot of water. And this is a world record that he did for the highest jump into shallow pool. And his name, I think here, was Professor Splash. Okay. Okay, so here is the video of the world record shallow dive. Let's watch it through twice, or maybe just once, I think. All right, so he's measuring the pool here, 1 foot deep. So in slower motion, see it, and he makes a landing. So he actually starts from 35.5 feet and then jumps up about 6 inches and then lands into the pool after a nice swan dive and a belly flop. Doesn't look very comfortable to me. All right. So in class, we are asked to analyze this video, but it goes way too fast for us to really capture all the places that he is. So we're going to start from where was he at 36 seconds. And we don't have the editing software to really be able to look at the video and pause it at the 0.2 seconds and 0.3 seconds. So this is the data that the curriculum collected for it. We're going to put this up here. So time in seconds, and then elevation in feet. And at time 0, we're going to start from the top of his jump. He was 36 feet up. Okay, so really he started at 35.5, but they count it from his jump up because you see him, he kind of launches himself up a little bit, about 6 inches. All right, so about a third of the second in, he's at 35 feet. Okay, and then about 0.7 seconds in, he's going to be at 30 feet. At 1 second in, he's going to be at 24 feet. At 1.125 seconds in, he's at 20 feet. And then at 1.33 seconds, he's at, 1.25 seconds, he's at 15 feet. And then at 1.33 seconds, he's at 11 feet. And at 1.5 seconds, he hits the pool. So you can see it in 1.5 seconds, he goes 36 feet. So in our video, it's 1.5 seconds long, and we can't pause that video fast enough to actually see all that stuff. But we do know from the lesson that we can get these data points if we had good video pausing techniques. So this is our 36 feet for the beginning. And then at 0.33 seconds, well, let's see, there's 0.5, so that's 0.4, 0.3 is going to be here. So we're somewhere on this line. So just a little past the third line, we're supposed to be at 35 feet. So somewhere about right there. And then at 0.7 seconds, he's at 30 feet. So 0.5 again down here. So there's 0.6, 0.7. So the seventh line over, we're supposed to be at 30 feet. So 1, 2, 3, 4, 5, 6, 7. And then at 1 second, we're at 24 feet. So 1 second and 24 feet is going to be about right here. Okay. At 1.125 seconds. All right, so that's just a little bit less than 1 second. We're at 20 feet. So a little bit more than 1 second, I mean. So about right here. And you can see, once again, we are speeding up. Okay. So 1.125, that actually should be past the next line. So about right here. Okay, and then at 1.25 we get 15. So 1.25 is the middle between 1.2 and 1.3. So right here. And 1.33 we're at 11. So 1.3 is there, 1.33 would be about right here. And there's 11. And then 1.5, he hits the water. Okay? And then he stays in the water, right, because that's done with the dive. So if we look at this one more time, you can see that we don't get a straight line. Instead, we get a curve. Okay? All right, so the name of these curves are actually parabolas, and our quadratic equation creates them. We're not going to learn the quadratic equation or the parts of parabola right now. We're exploring it, but we'll come back to it later in the year. But really, every quadratic equation is a parabola, and the curve of a parabola actually has two sides. So even though we didn't use the other side because it doesn't make sense to go backwards in time here, there really is two sides to this graph. Okay? All right, we have one more on our last page here. And on our last page, we have example 2. So the table below gives the area of a square with the sides of whole number lengths. Okay, so it has to plot the points in the table on the graph and then draw the curve that goes through these points. So we have this. A side of 0 gives an area of 0, because 0 times 0 for a square will give you 0. A side of 1, area of 1. 1 times 1, remember, for an area of a square. A side of 2 for a square will give us 2 times 2 for an area of 4. A side of 3 will give us an area of 9, and 4, 16, and so forth. Okay? So let's make our x and y axis here. We have to go up to 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then there's 16. Okay? And then we're going to do this one. Remember, this is going to be our area here for our y-axis. And then our x-axis, we have 1, 2, 3, 4, 5. Okay? And let's plot some points. So we know that a square of side 0, that's not really even a square, it's nothing, has an area of 0. But if we increase the side to 1, the area is 1. If we increase the size to 2, the area is 4. If we increase the size to 3, the area is 9. 4 will give us 16. And you can see once again, we get this curve coming. Okay? And then we're asked to reflect this curve on the y-axis. So that just means, remember, think about this as the mirror, and we move all of our points the same distance over. So this would be -1, -2, -3, -4. And we can reflect our points over. So we get here, at 2 we get 4, 3 is 9, 4 is back up here at 16. And you can see we get the other half of our parabola. Okay, and my left side's a little bit larger than the right side. Okay, so it really should be here, I think. All right, so that's all of the notes that we get from the book, those two examples on how to find, graph these curves. We're going to go back to our original notes, which are here. And the curve sections of our graph today were all partial graphs of quadratic functions, except for our last one when we reflected over, we got the whole quadratic function. And we'll spend Module 4 studying them in the near future. It's actually not that near. It's back in the second semester. Okay. However, we do have a definition of a quadratic function. A quadratic function is in the form of f of x equals ax squared plus bx plus c. So if you remember linear functions last year, this was y equals mx plus b, right? Just a regular x. Now we get an x squared. Okay. A, b, and c where numbers are not equal to 0, so we can't have a be the 0 part here. Okay. So the graph of a quadratic function is a curve called a parabola, and parabolas may open upward or downward and may vary in width or steepness, but they all have the same basic U shape. Okay. So a, b, and c cannot all equal 0. As a matter of fact, a can never be 0, or we don't get a quadratic. Now, we have one last question here. If you jump in the air 3 times, what might the elevation versus time graph of that story look like? So let's do that. Okay, I can jump all of about 1 foot. okay? And let's go over time here. So let's see, this is 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds. So if we can jump in the air 3 times in a row. Now, when I jump in the air, I start off fast, and then gravity grabs me, slows me down, and pulls me back. And as I go back down, I'm slow at the top, where I reach my peak of jump, and then I speed up as I get down. So for me, this is going to look something like this. Okay, I'm going to jump up, and then I'm going to go here, and then I might jump up again. Okay, notice my jumps are just a little bit more than a second. And then I might do this and jump up again. Okay, so we're going to get curves here again because we are changing the speed in which we are changing our elevation as we go. Okay, so gravity's acting on us. We start off fast change in elevation, but when we get to the top, we get slow. Okay, slower right here, slows down to 0, and then we start to accelerate again as we go downwards because gravity grabs us and starts pulling us faster downward. Okay, all right, this concludes Module 1, Lesson 2. And if you were out, hopefully this helped you, or if you were struggling, hopefully this helps you.